Hello, everyone. This is a short introductory conference on Coulombs Law. Coulombs Law is very useful to us in introductory level chemistry classes because it's the law that governs the interaction or the force between charged particles. That's interesting to us as chemists because we deal a lot in chemistry with electrons, which have a negative charge, and protons, which have a positive charge. So it becomes ideal for studying that interaction. Coulomb's law, the way I'll present it to you now, stems from Gauss's law. Now, I'll caution you that Gauss's law looks messy, but I promise we'll get rid of the messiness very quickly, and we'll boil it down to Coulomb's law pretty quick. So Gauss's law essentially looks at the effect of an electric charge placed in a cavity, and it monitors the flux of the electric field out of that cavity. So in short, if we have a cavity, not to be confused with a bubble, but a cavity, and if we put a charge, let's say an electron, has a negative charge inside that cavity, there will be a flux of field, an electric field will flux out of that cavity in every direction. We use the word flux. It's kind of like flow, but it's kind of not as well. So we'll use the word flux. Okay. So the equation says that if you sum over the whole cavity, so we basically want to sum up all these lines. So imagine this is a three-dimensional cavity. This long S means sum. The zero just means it's a closed system, like a cavity. And each one of these, let's say it's a unit area. So this occupies a surface area. This occupies a surface area. So we're going to sum over all of the surface areas dA. So sum over the surface areas dA, this just means the total area of our cavity. We want to sum over the total area for the entire electric field of this electron. So the electric field of the electron, and we know that that's equal to the charge, let's call it Q. So that's the charge of the electron over a constant we'll call epsilon 0. Now, this quantity here, the sum over all the individual areas, well, this is going to be the total area. Okay, so if we rearrange this equation, we rearrange Gauss's law, basically what Gauss's law says that the electric field of the electron inside the cavity is equal to the charge placed inside the cavity. We take this downstairs now. It's going to be the area times by some constant. So the electric field caused by a charge inside the cavity equals the charge itself per unit area multiplied by some constant. Okay. I've run out of space, so I'll erase this board. You can obviously pause the video. Let's say that area that we've just seen, let's call it the area of the cavity, which it is. So it's 4 pi r squared. That's the area of our surface area of our cavity. Okay. the surface area of our cavity. So this implies that what we've just seen, the electric field, because of the presence of the electron, equals the charge placed inside the cavity divided by A, but we're saying that A is 4 pi r squared, times by that constant. This constant won't really be important to us. For those that are interested, it's the vacuum permittivity of free space, but we'll just say it's a constant. The side equation, we know that the potential energy I'll call it V. So the potential energy because of the electron, well, we know that that is the charge of the electron multiplied by the electric field caused by the electron multiplied by the location of the electron. We'll call that R. If we now combine this equation into this equation, so in short, we're going to sub in for this value this whole equation here. And we have the potential energy of the electron is going to be this Q multiplied by this Q, because we're subbing in E for E now. So Q squared divided by 4 pi r squared E sub 0. And then we've got this R. Okay, so this is the potential energy. Okay, we don't just want energy though, we want the force. We want to express Coulomb's law in terms of the force between charged particles. So we're going to now comment, before we erase the board again, we're going to comment that the force on the electron is potential energy based on its location. Okay, and actually we'll probably be able to squeeze it in here. So this implies that the force on the electron is the potential energy, which is this value, Q squared over 4 pi. I'm going to replace the epsilon 0 and the r squared, so we'll say epsilon 0 r squared. Now I've got an r upstairs. I've also got an extra r downstairs. So this r will cancel this, and we just rewrite the force is Q squared, is the charge squared, over 4 pi epsilon 0 r squared. And this is Coulomb's law. Well worth remembering. It will be very useful to us in introductory chemistry.